Hi.
All right, so what we're going to do today is we're talking about two different types of equations, right? First equation is a thin lens equation where you're going to do 1p over 1q equals 1f. P is the object's distance, Q is the image distance, and F is the focus length. And then we have magnification of lenses, which is M equals the image height over the object's height, which equals the image distance over the object distance, okay? So if we look at practice problem on page 496, object is placed at 30 centimeters in front of the converting lens and 12.5 centimeters in front of the diverging lens. Both lenses have a focus point of 10 centimeters. For both cases, find the image distance and magnification below. So the first thing they do is they look at the F convergence, which is 10. That's the focus length. And then F divergent, which is negative 10, because it has to be negative because of the way that the mirror works. P converging is 30 centimeters, which is where the object was placed, right? And then P divergence is 12.5, which is the distance in front of the diverting lens. And it's asking you for Q's and M's. So the first thing that we're going to do is we're going to find Q. So what we're going to do is we're going to do our 1P over 1Q equals 1F. Okay, that's the thin lens equation. And so what they did is they're saying, all right, and then mass equals, M, not mass, M equals negative Q over P, okay? So they rearrange the equation to get the unknown by itself. After they do that, then they're plugging in the information. But there's something different that I'm going to do that they didn't do here. I just did the least common multiple. Were y'all doing it by least common multiple, or were y'all doing it the way that they did it here?
I was doing it the way they did it there.
Yeah, well, I'm interested to see how different it will be compared to what you have, okay? So then after we get finished with that, we have to, after we find Q, we have to find M. And then after that, then we have to find the diverging lens, which we're going to do pretty much the same equation, except we're using different numbers this time. And then we're using our mass to find that. Okay, so let's look and see what we've got. So the first one says predict how an object will appear if it is placed 20 centimeters in front of the conversion lens and the focus length is 10 centimeters. Find the image distance and magnification, describe the image. So first things first, our P equals what, guys?
That's 10, right?
Our P equals 20 centimeters. And then F is going to equal 10 centimeters, right, Jordan?
Oh, my bad. I was looking at the wrong.
So the first thing you're going to do is you're going to say P equals 20, F equals 10. So then we're going to look at the thin lens first. So we're going to do 1P plus 1Q equals 1F. Well, we're looking for Q. So we have to change our formula so that we're looking for our Q. So since we're not using that one, we're going to use 1Q equals 1F minus 1P. Have you done that so far? Is this how you did it, everyone?
Yes, ma'am.
Okay, Jordan, thank you very much. So what we're going to do is we're just going to plug and chug based on our information up here. So since this is going to be our equation, this is not because I had to rearrange it. Since it was plus, no matter why, it's minus because I'm changing it. So 1F is 1 over 10 centimeters, and we're going to subtract that by our 1P, which is 1 over 20 centimeters. So if I want to have the same unit, I changed it to 1 centimeter. So my fraction here is 0.100, and our fraction here is 0.500. One thing I'm doing is I'm just trying to find the least common multiple, and I just went through and did my math for that. Once we do that, the answer that I got was 0.0500 over 1 centimeter. And what is that answer that y'all got? Anyone?
I got 20.
I'm sorry?
I got 20.
20 centimeters?
Yes, ma'am.
So you got the same thing I did. I'm going to check my math real quick. So Jordan, how did you do yours?
The same way you have yours there, with your 100 divided by 1 minus the 0.5 there.
Okay. So if you did it straight on this way, without changing it to least common multiple, 10 minus 20 is what?
10 minus 20, wouldn't that be negative 10?
Negative 10.
Yep.
Okay. So if I did it this way, I would get 1 over negative 10. That would not give me the same number. Bailey, did you change yours to the least common multiple, or did you do it differently?
I did mine the same way you did yours.
Okay. Now, am I finished?
No, we still have to find the.
We're not finished, because now you got to find M. So M equals, and I'm going to use this image distance over object distance, Q over P, which I have 20 centimeters over my P, which is 20 centimeters. And my number is a negative 1.00, and this is a real and is inverted. Is that what you got?
Yes, ma'am.
Okay. Does everybody understand this?
Yes, ma'am.
Wow, good job, Bailey. I'm glad you do. Hunter?
Yes, ma'am.
Hayden?
Somewhat.
Okay. Do you have a copy down?
Yes, ma'am.
Okay, cool. Let's go on to the next one, number 2. Okay. Number 2 says, Sherlock Holmes examines a clue by holding the magnifying glass in an arm length at 10 centimeters away from an object. The magnifying glass has a focal lens of 15 centimeters. Find the distance in the magnification. Describe the image that he observed. Okay, so this one, I'm using a completely different equation, am I not?
Yes, you'll be using a different one.
Nope, I'm using the same one. I really like it how you go out on a limb. It's great. Thank you very much, sir. I appreciate it, because I would think so too. So the first one that we have is we have F, right? That's 15 centimeters. His P is equal to 10 centimeters. And we are looking for Q. So, yes, Jordan, we're using the exact same formula again. So, Hayden, what is the first thing I'm going to do?
Miss Long, my computer's froze up like the screen is. I can't see a thing. Hold on, I'm trying to get back on the
Well, that's
My
fine.
book.
It's all right. Bailey, what is it? It's okay. Bailey, what are we going to do?
We're going to put 1 over
Yep.
15 minus 1 over. Oh, wait. Okay. Minus that plus. Minus 1 over 10.
Yes.
And do we find least common multiple now?
Yes, ma'am, I would. So I,
Wouldn't that be 30? Oh, yeah, 30. Okay, I'm good. 30.
I'm
And so
good.
you would put 2 over the first one and 3 over the next one.
Yes,
And that
ma'am.
would be negative 1 over 30.
Which would be what number? Negative 30, right?
Yes, ma'am.
And that is my answer for that question. Do I have to do anything else to find anything else?
Yeah, you still have to find the M, don't you?
Nope, don't have to find the M on this one.
No, not this
The
one.
only thing it asked us for here was it to find the image distance. Oh, it did. Magnification. Sorry. All right. So to find the M, how do we do that? Well, we're going to do Q over P, Miss Lynn. All right. So my Q is negative 30, right?
Yes,
And
ma'am.
my P is 10. So that would equal 3.
3.
Right?
Yep.
Okay. Is it getting easier?
Yes, ma'am.
This is just like yesterday. These look intimidating and it looks like it's hard, but you do the same step over and over and over again. So the first thing that you're going to do is you want to go through and you want to find out the converting lens first and then the diverging lens second. What is the difference between the conversion and the diversion lens?
One is going in, or is bringing it to a certain point, and the other one is pushing it out.
Very good, Jordan. Very good. Wow, I like that. All right. Are we ready for number 3?
Yes, ma'am.
Yes, ma'am.
Fantastic. An object is placed at 20 centimeters in front of a diverging lens and a focus length of 10 centimeters. Find the image distance and magnification described in the image. So, number 3, I'm going to erase that, right? I'm going to erase this, and I'm going to erase this to start with. So, what do we have? We have P, right? Our P is 20 centimeters. And our F is negative 10 centimeters. We are looking for Q again. Okay? So, Jordan, you think you got this?
I believe so.
Okay, sir, tell me what we're doing.
Alrighty. Well, you have to do 1 over. I like to do 1 over P plus 1 over Q. That's how I did the last one, actually.
Okay.
So you'll have, I believe it's 1 over. Yeah, that's right. But yeah, they're on the board.
So what's my equation?
It should be. Hold on.
One over negative 10 centimeters minus 1 over 20 centimeters, right?
Yes, ma'am.
Doing 1F, subtract 1P. Now, I chose 1 centimeter again. So if I chose 1 centimeter, this is 0.100, and then this one is 0.0500. Is that correct?
Yes, ma'am.
Equals 0.150 over 1 centimeter, which means that my Q should equal negative 6.67 centimeters. Is that what you did, Jordan?
Yes, ma'am.
Okay, so then I'm looking for my my M, magnification. I keep wanting to say mass. So my magnification is what? It's going to be my Q and P again, right? My image distance over my object distance. So I'm going to do Q over P. So what is my Q?
The 6.671.
Okay, negative 6.67 centimeters over my P, which is
20.
20 centimeters, what equals what?
It should be negative 0.3335.
I keep lagging.
And that is my M, correct?
Yes, ma'am.
Everybody good? Are you getting the flow of it?
Yes, ma'am.
Hayden, are you getting the flow of it?
Yes, ma'am. All I can do is hear. My screen's froze up.
That's okay, baby. This is what I'm doing. I'm videotaping it. So if you need to see what the screen looks like at the end, you can.
Yes, ma'am.
Okay.
Yes, ma'am.
Jordan, do you understand the flow of it?
Yes, ma'am.
I mean, the only thing we're doing is we're going through, we're erasing our variables, we're plugging and chugging what we did before. Always make sure that you want to do the least common multiple. Even if you use a different least common multiple, you're probably going to get the same answer at the end anyway. Because when you start doing your factoring in of how you do that, then you'll get that. Would you like to do number 4?
Yes, ma'am.
Okay.
For the question before this, I did something like a little bit different than this one. Where we did the 1 over 15 and we're trying to do the equation there. I just when we got to Q, I did 1 divided by 0.3, and I actually got the negative 30 that we're supposed to use.
So what number did you get for A, Jordan?
For number 2?
For A, for number 4?
Oh, I haven't done number 4 yet. I was talking about number 2. The problem.
Yes, sir. How about number? Say that one more time. I didn't hear you quite.
Oh, okay. I was saying for number 2, when I was doing the equation, I did 1 over 15 and then 1 over 10, and I got, or negative 15 and negative 10, I got negative 0.30 there.
Yes.
And then I just divided that by 10 or negative 10 to get my 3.
Yeah. And like I said, you can do it the way that the book does, or you can do it my way. It doesn't matter. Both of them should come out the same at the end. It's just easier for me to do these common multiple, and I just do it that way. But as you can tell what Jordan says, you can do it, the book has it, where you're just going ahead and doing a straight factorization. You'll still get the answer at the end, so you'll be fine.
Okay. I wasn't sure which one to use at first, but I understand.
I prefer whichever one makes sense to you.
All right.
Okay, so I mean, it doesn't matter to me. I think we're both going to get on the same roadmap. Okay, so let's look at number 4. Number 4 is set up just a little bit different because it's in a data table. On number 4, it says fill in the missing values of the table. So what they do is they give us a conversion lens. It gives us the F. We're having to find the P. It's giving us the Q, and we have to find the M. It's the same thing we're doing, except it's on a data table. That's all that's different, okay? So for the first one, 4A, we have F equals 6.0 centimeters, and our Q equals negative 3.0 centimeters. Yep, we got. So the first thing we're going to do is we're going to have our equation, 1P equals 1F minus 1Q. Okay. So what we're going to do, we're going to do 1 over 6.0 centimeters minus 1 over negative 3.0 centimeters. I went back and I changed them. I think I did this one straight way. No, I didn't. So then what I did is I changed it to 1 centimeter. And so I have 0.017 and 0.33 negative, which I got 50 over 1 centimeter, which means P equals 2.0 centimeters. My M equals negative Q over P, which is negative 3.0 centimeters over 2.0 centimeters, which gave me 1.5. Is that what you got for 4A?
Yes, ma'am.
Yes, ma'am.
Good?
Yes, ma'am.
Okay. So the only thing you have to do for B is the same exact thing, except you're using 2.9 and 7.0. And then if we look for C, diversion lens, which I'm going to do one of them. What we're going to be doing with that is we're going to do what with that one? It doesn't even look like I did it. Isn't that so sad? I did A and I stopped. Oh, God bless us. All right, if you'll give me a second, let me get this done and I will come right back to you. Go ahead and work on number 4B for me real quick, and then we'll check the answer together. Where's my calculator? Okay, so let's look at C. So for C, it's giving us a negative 6.0. Yep. And then it's giving us 40 centimeters, and we have to find Q and N. So let's go ahead and do that equation. So remember, it's either this or this, depending on what we're doing. So for this one, we're going to do 1Q equals 1F minus 1p. My F is 1 over negative 6.0 centimeters minus 1.4.0 centimeters. So my 1Q, I changed it to 1 centimeter both. And I made this negative 0.17. And I made this 0.25, which gave me 0.42 over 1 centimeter, which gives me Q equals 2.4 centimeters. And for my M, I got negative Q over P, which is negative 2.4 centimeters divided by 4.0 centimeters, which equals 0.60. That is my answer that I got for number for C. Now, what did you get for B? What did you get for P and what did you get for M?
I got 0.20 for P, and for the M, I haven't got that one yet.
Okay. Anybody else got a different answer than that? All right, Jordan, I'm going to do it over here and I'll show it to you in a few minutes. Yeah, it was right. All right, Jordan. Can you see B?
Yes, ma'am.
All right, so where was your problem?
I believe I have the wrong numbers.
Okay.
I got the same thing you did, Miss Sloan.
Okay. I have this on the video, so what I'll do is I'll just put it up for y'all so y'all can look at that. But listen, I know. Are you listening? I know this is the very, 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 very last thing you want to do today. Because it was the very, very, very last thing I wanted to do today. But this is the thing I want you to think about when you come in tomorrow, okay? We've learned all this information about different types of lenses, about reflection. We've learned about the Snell law. We've learned all these things. And what we're going to try to do is we're going to finish up tomorrow in section 3, but then we're going to go back into my computer room or my Project Lead the Way room. And what you're going to do is see if you can see it or not, okay? So what you're going to have is you're going to have the light boards that you were using the other day with the mirrors and all that. But this time what you're going to do is you're going to have a piece of graph paper that you're going to put on the bottom, okay? You're going to create a problem and you're going to draw it on the graph paper and you're going to do the math. Now, the question that I need to ask you, do you feel like you can do that tomorrow?
Yes, ma'am.
Yes, ma'am.
Hayden? Yes, ma'am. Okay, Hayden, good. Thank you. All right, well, like I said, I really appreciate all the work that you are doing. I know this, like I said, is the last thing you want to do with all this math. But can I tell you that we should be able to tie what we learned last week to what we learned this week together and be able to apply it in a lab setting. So I want you to think about, because you've used this equipment before, except the only thing that you didn't do, you didn't use the graph paper that's on the bottom, and we want to see if we can. Now, listen, if we're successful or not, does it matter? No. The thing about it is I want you to have the experience of being in there, looking, drawing. So you're going to have some kind of phone or something with a light on it because it's going to be dark. So you're going to have something that you can shine so you can see. I'm going to try to see if I can get some of these flashlights to work here, and maybe that'll help too because the lights have to be off because different people are going to be in different places when they're working. Everybody understand?
Yes, ma'am.
All right, guys. Well, I mean, unless you have questions, do you have questions about anything from today?
I think I'm good.
Oh, good.
Okay. All right. Well, great then. I'm going to put this video up for everybody else. And those of you that need to look at the math, I'm going to have it up so you can just fast forward it to that math part so you can look and see what's on the board. Okay, guys? Thank you again. I appreciate it. And I will see y'all tomorrow.
See you tomorrow.
See you tomorrow.
Bye, baby.
Bye.
Bye, guys.